Hey guys, what's up? It's Mr. Miller here. It is Friday, April 6th. It is around 6 o'clock, actually 2 minutes till, and I'm still at work. Can you believe it? I have no life, do I? Alright, in this video, we're going to be laying the groundwork for what you're going to be needing in order to uh, simplify these rational expressions, which is really the main topic. This video, as it says in the title, is a review of factoring. So what that implies is you have already seen how to factor things. You may not remember it, and that's okay. That's why we're doing a review. But we are going to be doing so much factoring. You're going to get sick of it. We're going to be doing it for weeks and weeks and weeks on end. This is a really, really big thing in Algebra 2 because we need factoring in order to handle dealing with rational expressions. So it's very important that you sharpen your factoring skills because you want to get quick at this. And that just comes from practicing. We're going to start off with examples right away. I'm not going to get into any vocabulary or anything like that. We're just going to go straight into, let's do some examples. So the directions here say to factor this completely. Now, here we go. It's tweaking already. Factoring means to make it a multiplication problem. And what we want to do is we want to figure out what's the biggest factor of this thing here. Whoops, already wrote on it, my bad. What's the GCF? The GCF of 4x and 6. All right, let me do that down here. GCF. All right, that's our first step. We need to find the GCF. What's the biggest number that divides into 4 and 6 evenly? If you said 2, kudos to you. That's correct. It's 2. Now, how many x's can we take out? When we're factoring with variables, we always go with the smaller exponent. This x has a 1 on it. This 6 has no x's. 0 x's. X to the 0. What's the smaller of the two exponents? X to the first versus x to the 0? And by the way, x to the 0 would just be 1. And for that reason, we don't put x to the 0 after 6. It would just be cluttering up what might already be, in some problems, a mess. So we're not going to write x to the 0. So how many x's do those two things have in common? Here's our first piece. There's our second piece. 0, right? They have no x's in common. So we can factor out 0 x's. Our GCF is just plain old ordinary 2. So we're going to put our GCF on the outside of our parentheses. Now we have to decide what to fill in the inside with, and we don't just get to willy-nilly pick and choose. What would I multiply 2 by, my GCF, to take me back to 4? Oh, that's 2, right? I had an x. I'm not taking any x's out. How many x's do I have left? A single x. I didn't lose any x's because I wasn't taking any out, right? What do I multiply 2 by to take me to 6? 3, right? There you have it. We've just factored this thing. Let's look at a maybe slightly more complicated example. That's pretty simplistic. Where is my... Here we go. All right. Now take a look at this thing. This thing is a little bit different. The last example was linear because the highest exponent on the letter was a 1. The highest exponent in this problem is 2. X squared. That means it's quadratic. X to the second, or W to the second, or T to the second. The letter doesn't matter. But when you have a letter to the second power, and that's the highest exponent, that is a quadratic. And with quadratics, they're a little bit more difficult to factor. So let's review that. The first thing we want to do is take out the GCF if there is one. Well, everything's going to have a GCF, but what I mean is if the GCF is 1, then that's not going to change your problem, right? Because if you factor out 1, you're just going to get the same problem back. So if we have a GCF other than 1, we really want to factor that out. So let's think. Biggest number that goes into 1, 5, 6 is 1. Let's look at our variables. X squared, x to the first, no x's. How many x's are common to those three pieces? 0. So the GCF of this quadratic, this polynomial is uno, just one. All right, so we can't factor anything out of it. Now, that doesn't mean we can't factor it. Let's take a trip down memory lane. This x squared has a 1 in front of it. 1 means naked, right? I can't believe I'm saying this. This could be broadcasted, across the world, and I'm talking about naked in a math video. That's terrible, isn't it? But it's naked. It is, all right? So naked is good because naked is going to be easy to factor. We need two numbers that multiply to our back end, which is 6. But those same two numbers have to add to the middle, which is 5. What two numbers multiply to 6 but add to 5? Oh, you guys are so good. 3 and 2, right? You knew that. 3 and 2. Very good. Now, we're going to break up x squared as x and x. Right? We do these two parenthesis deals. Boom, 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 right? X, x, and then these two numbers that we used to find what multiplies to 6 and adds to 5, these two numbers drop down into our parentheses, right? Positive 3, positive 2. We factored. We're done. That's it. All right? Hopefully that's jogging your memory a little bit. Okay, we did these last semester. Now, I know I'm moving fast, but that's because this is a review video. I'm sorry. If you need to, pause the video, take a minute to think about it, rewind the video, watch again, and if you're still stuck, then call me over and I'll be happy to clarify. All right, now, what I want you to do is pause the video and try this example on your own, hit play, and check your work. Okay, all right, let's go over the answer now. It's GCF is 1. The greatest common factor of 1 is -7. -8 is 1. Wonk, wonk. Too bad, so sad. What about our variables? X squared, x to the first, no x's, or x to the 0 if you like. How many x's do they have in common? They have no x's in common. These three pieces have no x's in common, all because of this little -8 at the end, just spoiling it for us. That -8 has no x's. But that doesn't mean we can't factor it just because the overall GCF is 1. Let's try to factor this thing. We need two numbers that multiply to -8. Those same two numbers have to add to -7. What two numbers multiply to -8 and add to -7? Whoo, Shazam, you guys are so good. -8, +1. -8, +1. Whoo, grease lightning. We're going to break up our x squared as x and x. These two numbers, the lucky lotto numbers, the numbers that made the magic happen, drop down. -8, +1. That's it. We factored this. Beautiful. All right. The next example is going to get slightly more complicated, but I'm going to be honest with you. The next example is pretty much as hard as factoring is going to get. Let's take a look at our next example. Oh no, this one isn't naked. This is a dressed quadratic. Oh my goodness. Oh, just when things seem like they were going so well for us, and now we have to deal with this dressed quadratic. All right, so first of all, let's see if there's a GCF. Biggest number that goes into 2, -1. -3 is 1. No help there. Too bad, so sad. Let's look at our variable. 2 x's here. I'm talking about the exponent now, not this 2 that's in front, but the exponent. 1x, x to the first. No x's here. 2 factors of x here. 1 factor of x there. No factors of x here. No x's in common. No points this round. Okay, so the GCF is 1. That's not going to change our problem. Now, let's talk about how do we factor this thing. To factor this quadratic, we have to take into account we have a number in front of our x squared. And to take that into account, we multiply a front end times a back end. 2 times negative 3. What do you got? How much is that? 2 times negative 3. Negative 6. Very good. Same rules apply. We need a number and another number that adds to what's center stage, right there in the middle, negative 1. What two numbers multiply to negative 6 but add to negative 1? Negative 3, positive 2, right? Makes some sense? Negative 3, positive 2? All right, beautiful. This is going great. Now, if this isn't messy enough, it's about to get messy. So brace yourself. We cannot simply do this. I'm going to show you the wrong way first, which I don't like doing because then sometimes people end up doing that, but I think here we'll be okay. How come this doesn't work? This doesn't work because x times x is x squared. We need 2x squared. All right, and you can try to put a 2 on that x and a 2 on that x, but there's no guarantee that that's going to give you the correct factoring. So we don't want to be guessing to factor addressed quadratic. We want a tried and true method that's going to get us the correct answer each and every time. The process might seem lengthy at first, but once you get the process down, you practice. It's like tying your shoes, right? First learn to tie your shoes. I bet you may have felt like this is something that you were never going to achieve. It seemed like it just had too many steps, but you conquered, you persevered, you stuck with it, and you conquered it. And the same can happen here. You just have to be willing to put the time in and practice. Now, what time is it? Not nap time, not lunchtime, although I am hungry. It is table time. Oh my God, table time. Always a great time. Table time is always a great time, right? How do we fill this table in? All right, let's review that. First piece, first box. Shazam, dropped it right in there. Last piece, whoop, last box, negative 3. Now we have 2 boxes left. Oh, you know, looking at that box, it almost makes me want to play tic-tac-toe now. I'm getting off on a tangent, I'm sorry. Okay, what are we going to fill in these 2 boxes with? Well, we have these 2 numbers that we found that we haven't done diddly squat with. Ignore that garbage, right? That was the wrong way. Don't you dare do it this way with addressed quadratic. Oh my God, you will see a side of me you will not like to see. Don't you dare do it. I'm kidding, but please don't do it. These 2 numbers we're going to drop into the remaining spaces. Doesn't matter the placement. The negative 3 could go in the upper right or the lower left. Who cares? Doesn't matter. Pick a spot and roll with it. What do we attach to those 2 numbers? X and X, whatever our variable is. All right, and I'm lazy, so sometimes I don't change the variables up as much as I probably should to make the videos more of a variety. But it doesn't matter if this were a W or a T or an R or whatever. Whatever the variable is, it's going to attach itself to these 2 numbers. Okay, now, factoring out GCFs, very important that we can do that. We're going to ignore the bottom row for now. We're going to focus on the top row, going left to right. What's the biggest number that goes into 2 and 3? 1, right? Bada bing, bada boom, 1. How many X's do these 2 boxes have in common? Well, there's 2 X's here. I'm looking at the exponent now. 1 X here, 2 X there. 2 factors of X, 1 factor of X here. We go with the smaller exponent. We can take out a single X, X to the first. I'm not going to write the 1 in just because it's not needed. We don't have to, but we could if we wanted to. What's the GCF of this bottom row now? Biggest number that goes into 2 and negative 3 is 1. And remember, this box closest to where we're factoring, that sign has precedence. It carries. It's positive here, so this is going to be a positive 1. Let's take a look at our, excuse me, sorry. First column, what's the GCF of 2x squared and 2x? Let's start with the numbers. What's the biggest number that would go into 2 and 2? I think 2, right? I'm sure you said the same thing. How many x's do they have in common? Factors of x. To determine that, we look at our exponents. 2 factors of x here, 1 factor of x there. We go with the smaller exponent. The smaller exponent is 1, so we can take out an x to the first, but I'm not going to write the 1 on the x because it's not needed, right? Last column, GCF of -3 and -3. Biggest number that goes into 3 and 3 is 3. The sign closest to us, all right, carries. All right, we're factoring this columns. The sign closest to us carries, -3. Now, the information on the left and the information on the top is how this quadratic factors. So let me go down here. All right, equals. Here's how this quadratic factors. It factors as x plus 1, 2x minus 3. All right? Now, what do you think's coming next? Oh, you're so good. That's right. You're going to try one on your own. Have a go with this. It says factor completely. Try that one out, pause the video, work it out, and then check your answer. Okay, guys, let's go through the motions of how to factor this thing. First of all, it's quadratic because the highest exponent on the variable is 2. What do we do next? We check to see if it has what its GCF is. Everything's going to have a GCF, but if the GCF is 1, who cares? It's not going to change the problem that we're given. It's not going to have any effect on it. GCF of 3x squared minus 11x is 1, so that's not going to have any effect on the problem. It's quadratic. It's not naked, it's dressed, so we got to multiply front end times back end. Let me switch colors here. I don't know if you guys can notice it or not, but I am really thirsty, so if you hear me swallowing a lot, I'm sorry. It's probably an annoying sound to hear in your ear. Mr. Miller swallowing. Okay, number 11, which is negative. The number in the middle is -11. Now, what two numbers multiply to 30, but adds, to -11? I wonder. How about 6 and 5? 6 and 5? Does that work, 6 and 5? I don't think so. 6 times 5 is 30. Yay, hooray! But 6 plus 5 is positive 11. How can we fix that? The simple trick is, let's put negatives on the 6 and the 5 and see if that does the trick. -6 times -5, bada bing, bada boom, 30. Works out. -6 plus -5 and -11. Perfect. We've got the numbers that make the magic happen. Now what time is it? You got it. You're so good. It's table time. Let's do our little table and start filling our table in. What's going to go in the first box? First box, upper left, 3x squared, right? Bottom right-hand box, 10. Along the diagonal, I'm going to drop these two numbers in. -6, -5, the placement doesn't matter. -5 could have gone up here where the -6 is, and the -6 could have gone down there where the -5 is. Doesn't matter. What do? We attach the to each of those two numbers, and now we start factoring out GCF of each row and each column along the left. So we factor along I recommend factoring along the left and along the top. The GCF along the first row is 3x. The GCF along the bottom row is -5. They only have one factor of x in common. The biggest number that went into 3 and 6 is 3. In the bottom row, The biggest number that divides into 5 and 10 is 5. They have no x's in common because although this negative 5 has an x, the 10 does not. They don't have any x's in common. The 10 has none. So how can you say that they have any x's in common if 10 has no x's when the negative 5 has an x? They don't have any in common, right? You get the idea. I'm just babbling. Why did I put a negative there? Because the sign closest to me carries. Now let's do the columns. Yes, let's, right? Yes, Mr. Miller, let's do the columns. Why not? What's the GCF of 3 and 5? 1, right? What's the GCF of x squared and x? Well, we go with the smaller exponent. This has 2 factors of x. This has 1 factor of x. This box has 1 factor of x. We can take out an x to the first, a single x. And like I said, I could put a 1 on here, but there's no reason to. 1 doesn't, it's not necessary. But if you do put the 1 there, I won't mark it wrong. It's okay. GCF of 6 and 10. Did you say 2? I would have to agree with you. But what about the sign? Box closest to us carries, right? Negative 2 for the GCF of that second column. All right, guys, we have it now. This piece and this piece along the top and along the left is how this guy factors. So now we have 3x minus 5x minus 2. And there you have it. A nice review of factoring quadratics. Thank you for watching. Please watch the next video on simplifying rational expressions.